Hey guys, we are here with the 1325 exam review. That's going to be here, so in person. Actually, let me get the link for everyone. That way, everyone is.
So you've never had a threesome?
Mm,
Like, as far as like.
It's been work stuff. Not even one.
Never once. I haven't had a single summer in college where I
Oh.
had a boss. And I was like hoping to get a full-time internship too.
Not sure how that works, but anyways, we're just gonna go here. So we've been going through the two's complement. This is like the exam practice questions, basically. So the person I'm with is pretty confident in their two's complement. Basic breakdown of that, I'll just go through this for the people here, is going to be you're going to invert all of the numbers. So this would be 001, 00110. Then you add 1 to the least significant bit, which is the one on the rightmost side. And that the answer you get from there is going to be the two's complement of the number. The reason you would use this is, say, if you have a number that starts with a 1, that means the number is initially negative. So the most likely question you'll be asked is to find the magnitude of the number if it starts with a 1. And so what you're going to need to do there is invert, add 1, and that's going to be the magnitude of the answer in binary. From there, you're going to need to convert that to decimal. And so the conversions I'll go into after I finish this part of the talk. The second use case is if they give you a positive binary number and they ask you to negate it. So that's going to be the same thing. You flip the bits and then you add 1 to the least significant bit. To convert from decimal to binary, you're going to basically go from least significant bit to most significant bit. The least significant bit has a value of 2 to the 0, which is 1. The next bit has a value of 2 to the 1, which is 2. So it goes 1, 2, 4, 8, 16, 32, 64, whatever, right? And so if there is a 0 in the value, you do not add it to the total sum. And if there is a 1, you do add it. So in this case, you would have a 1 plus 0 times 2. So this would be 1 times 2 to the 0 plus 0 times 2 to the 1 plus 0 times 2 to the 2 plus 1 times 2 to the 3, so on and so forth. You add them all together and then you get your value in decimal. How you would convert from a decimal value into a binary value or into any other type of number system value is you would start with, actually I don't have it depicted here, so it might be a bit difficult if me just explaining, but if you look in the notes I'll post afterwards, it'll be a bit more clear. So you start with your decimal value, say it's going to be 32 or 31, for example. What you're going to do is, if we're converting to binary, you divide it by 2. The remainder is stored in the results column, and then I don't know what it's called, the result of the division is stored in a separate column. The result of the division comes back to the beginning. You divide that by 2 again. You store the remainder. You store the actual number. The actual number goes down again, and you proceed until you end up with 1 at the bottom, and then that is going to end up being your 1 divided by 2 is going to end up being 1 remainder 0, and it's going to be 0 remainder 1, and once you have 0 in that first column, you stop. And then you write the number from the bottommost remainder upwards. So if you look in the notes, it should be explained a bit clearer there. But yeah, I think that's pretty much it. This second one, the symbolic constant, size with a value 100. So a constant in C is going to be basically it's a type of variable, but it's going to be a variable that does not change. So you have like a box, for example, that's what all variables are, but for constants, you're just going to like super glue the lid on top of it after you put the value inside. And the reason you don't put a semicolon after the statement is that this is just for the program's information. You're not telling it to execute anything. You're not telling it to process anything. You're just saying, hey, by the way, whenever I say size, I mean 100. That's pretty much it. Identifier names, there's one quick rule, and that's you just can't begin with a digit, and you can't have any special characters in the name at all. You can begin with an underscore. It's just people are going to look at you like you're weird if you do. So don't do that. Otherwise, yeah, go for whatever you want, and they are case sensitive. So as it says here, lowercase a1 and uppercase a1 are 100% different identifiers. I believe y'all's exam is open book, open note. So if you guys have your slides open, you can do what I did and just like control find the keyword and then go from there. Because might as well use your tools and that you have available to you. All right, I think that leads us to where we were now. So the operators. So the question asked, what is the value of z after you do this operation to it? So the 3 bar 7 is not, it looks like division at the first glance, but it's not. So the bar operator, actually let me go into operators real quick. Operators are like symbols that tell you a specific process to do on the two numbers to the side of it, in front of it, whatever. So the bar operator here means bitwise OR. So what you're going to do is you're going to convert the number on the left and the number on the right into their binary components. Then you're going to do an OR operation on each component in line. So 3 and 7, right? So 7 is going to be 1, 1, 1. 3 is going to be 0, 1, 1. When you bitwise OR them, 1 and 1, the OR of 1 and 1 is 1. The OR of 1 and 1 is also 1. And then the OR of 1 and 0 is going to be 1 as well. So the bitwise result of this operation is going to be 1, 1, 1. Converting that back into decimal, that's going to be 7 as a result. So a quick little cheat you guys can use for your operator truth tables is going to be OR is O optimistic. So if you see a 1 anywhere in the operation, you know that the end result is going to be a 1. The only time the end result is not going to be a 1 is if both of the values are 0. So a 0, 0 OR is going to leave a 0. Like even an OR can't work a miracle, right? But if there's two ones, it's very happy. If there's 1, 1, it's going to be like, okay, I'll give it 1. The AND operator, which I believe is going to be an AND sign, is 2 AND signs or 1 AND sign, I do not remember, is going to be, it wants symmetry. So if you have a 0 and a 0, it's going to return a 1. A 1 and 0 doesn't like that, returns a 0. 0 and 1 doesn't like that, returns a 0. And the 1 and 1 is going to return a 1 as well, because those are the same. So those are the two most common operators. There's a bunch more. To figure out what happens when you do an operation on them, you can look up what's called a truth table. And that is what's going to basically say, like, okay, if you have X variable and Y variable, what happens in the output after you do the process to them? So that is my suggestion on the operators one. Going into the flow control example, right? What happens here is you have printf of this value, and then it evaluates what's happening here, and then if it's true, it prints it matters, exclamation mark, and if it's not true, it prints it does not matter, exclamation mark. So this might be a little tricky if you're not sure exactly what's going to go on. So c equals 3 here, right? In this if statement, it actually executes what's going on in the if statement. So it's going to print exclamation mark, comma, no matter what, right? After printing that, it's going to then evaluate, is the statement in here true? Now, initially at first thought, you're going to be like, of course, 3 does not equal like a print of two values, right? A print of like two characters. However, the way C is weird. It actually evaluates this printf statement here to be 2 because there are two characters being printed. Does that make sense?
Mhm.
Okay, so it's going to see, is 3 equal to 2? It's not, so it's going to print the second statement. It does not
okay.
matter. So that is why the answer is going to be exclamation mark, comma, it does not matter, exclamation mark.
We also include the this part as well.
Yeah, so it's going to first print that part in the if statement,
Yeah.
and then it's going to print the else statement.
Okay. Okay.
So it's going to first print what's happening there, no matter what.
Mhm.
And if once it evaluates that, then it's going to go down and be like, okay, I can do this, I can do that.
Okay.
One caveat, though, I would say, is if you have a single equal sign, it's going to always return true.
Oh, okay.
So you will mess up your program if you put an equal sign. If you're thinking in like human level, like
Yeah.
3 equals 2, right? The computer is going to be like, oh, okay, well, you're telling me it's true, so
Yeah.
I'm going to assume it's true.
Okay.
So equals is actually an operator as well. It's called the assignment operator. And
Oh,
what it
okay.
does is it assigns the value on the right to the variable on the left. So what happens here is that 3 is put in the box of C.
Okay. Yeah.
What'll happen here is if you say C equals 2, it's just going to take 3 out of the box and put 2 in the box. And then it's just going to return true. It's like,
Yeah.
you're telling me it's true, you're the boss. I'm just going to go with being true,
Okay.
right?
Yeah.
So it'll never return false.
Mhm.
So if you're debugging your programs and you find something that's just not working,
Mhm.
check your logic statements and see if your operators are correct.
Okay.
Mhm.
Good one.
Cool. Oh, my bad. Okay. Going into the operators and flow control. Wow, this computer is laggy. Anyways, cool. So this is just going to be a basic way of starting out. You write the number and then you do a little table that you can do that'll be like, okay, on the first iteration, the value of I is 1, then you say true, and then it'll print. And so you can increment the counter of hello, the amount of times hello is printed by 1, because that's what the question is asking, right? Then you go to the next loop and you say, okay, the next time it's going to be 2.
Yeah.
2 is less than 10, it's going to print hello.
Oh, okay.
It's going to do that 9 times.
Yeah.
The reason I know it's 9 times is that what happens here, right, is it says plus I is less than or equal to 10. So the plus plus is also an operator. It's a basic shorthand for saying I equals I plus 1. So what's going to happen is that the value of I is going to be increased by 1 and then assigned to the value of I, right?
Okay.
So it'll be the value here, it'll be 2, and then it'll evaluate. There's 2 ways you can do it, actually. You can do a plus plus I, or you can do I plus plus.
Okay.
So if you do plus plus I, it'll increment the value of I first and then evaluate.
Okay.
If you do plus plus after the I, it'll evaluate what's in the loop and then increment it afterwards.
Okay. Okay. That makes sense.
So what'll happen on the like the ultimate loop or the final loop is going to be the value is going to be 9 coming into the loop. So it's printed 8 times. It's
Yeah.
going to be 9 coming into the loop.
Okay.
It's going to increase it to 10. Then check if it's less than or equal to 10.
Yeah.
It's equal to 10. So it'll print it the 9th time.
Okay.
Right? But the issue is if this was just a less than sign, it wouldn't print it the last time.
Oh, okay.
So it all depends on like what you want your code to do. So you have to map out the flow properly.
Okay.
That's just one of the reasons that it's going to be doing that. Cool.
Oh, okay. Okay. Now I get it.
Yeah. So this is going to be while p is greater than 2, it's going to be p is going to be divided or equal to 2, right? So let's hop in. Did you guys cover integer division?
Yeah. I don't know if I was there for it, but I remember they did some problems with it.
Got you. So if I have 75 and I divide it by 2, what's the answer going to be?
So, could I like do it in my head?
Yeah, for sure. You can also use paper, but what's going to happen?
This is one thing I know about integer division is that you can't have remainders. That's
Mhm.
one thing I know. Would it give you 1?
No.
No. How does that work?
Oh, yeah, the final answer is going to be 1. Yeah.
Yeah.
Yeah, for sure. Try it. It is 1, right?
Oh, it's gotta be 2. Oh,
That is true. So we ran into an issue here, right? So you start with the integer division, and then you're gonna drop the remainder. It's gonna be 37. Drop the remainder 18. Drop the remainder 9.
yeah.
4, and then 2. Right.
When it hits 2.
Then you're on the edge case here. So while 2 is greater than 2,
Mhm.
you're going to do it. But 2 isn't greater than 2.
Yeah.
If you kept going, then it's just going to return 1,
Yeah.
right?
Mhm.
But what'll happen is once you hit that remainder, it's going to be, is 2 greater than 2?
Mhm.
You evaluate it and be like, oh, it's not. Let me just
Yeah.
stop. So
Okay.
it'll return 2 at the very end.
Oh, okay. Okay.
hmm Is that what it said?
There.
Yeah. So is 2 greater than 2? Since the condition is false, 2 is not greater than 2. It's just going to stop. And it's going to be 2.
Oh, okay. Yeah.
Yeah. So we're going into this one, right? It's going to be a little bit of a for loop.
Yeah.
Um, what's like the glaring issue with like what the for loop's going on right now?
Is there?
Because like what's a for loop syntax supposed to be like? Like normally when you put it in.
I actually don't know.
Okay, no worries, no worries. So what you do at the for loop, right, is you initialize the variable, you have a condition, and then you do something afterwards.
Mhm.
So how it goes is that the first block will always execute. So this counter equals 1 will execute before the loop even starts.
Yeah.
Then it's going to check the condition in the second block of code, which should be separated by a semicolon. So obviously we know it's just not going to compile,
Oh, okay.
right? There's supposed to be 3 parts of the for loop, and there's only 2 here.
Oh, okay. Okay. Yeah.
The second part is just going to be, is this condition true? If you wanted to just loop no matter what, you just put 1,
Mhm.
which is like true, basically.
Yeah.
It's just a shortcut, quick and dirty, just be like 1, or you can do 1 equals 1 or something like that, right? But what you usually put it as is you put while counter is, or you only have to put while, right? For loop is a while loop. You just put counter less than 1, or counter greater than 1, or counter less than 10.
Yeah.
So it'll loop that amount of times as you work through your flow. And then the last part of the statement is going to happen after everything.
Yeah.
So it'll increment counter after the program is done.
Oh, okay.
So yeah, it's just going to straight up not compile here.
Okay.
Cool?
Yeah.
Are you taking discrete, was it signals and systems?
Yes.
Okay. Can you help me out with this? After this?
Yeah, for sure. Probably be like an hour, realistically though. Yeah. When's your like? Is it like an exam you need to? Okay. Got you. I'm free around like 4 to 5 if you're free then. Cool. For sure. Yeah. So, is that everything for there or?
Yeah. For this one, yeah, it's pretty much done.
Okay. Cool. Let's go into the operators. So we have y equals x divided by z. Okay. So what is x? X is an int, right?
Yeah. It is.
And then z is going to be a integer as well. So that's going to be integer division.
Okay. Okay.
So 21 divided by 14 is just going to be what?
Yeah.
Okay.
She hasn't responded yet. She's at work. Alright, goodbye.
Okay. Gonna equal to 1.
It's just going to be straight up 1, right?
Yeah.
Okay, so the value of 1 is going to be stored into y. Then you're going to do w equals 5.5 times y. If this was integer multiplication, it just wouldn't. It would be a different case. But since y initially here was a double, we're okay with multiplying it by 5.5.
Oh.
So what's the final answer going to be? Just 5.5.
Yeah.
If it was a integer, it would just drop the 0.5 and it would just be 5 as the answer.
Oh, okay, yeah.
Right? But since y is a double, you can do normal multiplication on it.
Yeah.
Right?
Oh, okay.
So the answer is going to be 5. 5.5 is if y was an integer.
Okay.
Right?
Yeah.
So it's like the different types of boxes. So there's an integer box and like a double box.
Yeah.
So the integer division is stored in a double box, and it's
Oh.
now a double.
Okay. For the double.
It automatically converts the integer into a double.
Okay. So why do we like kind of like ignore these values?
Because they weren't used.
Oh, okay. Oh, okay.
We only really used y.
Okay.
You could have just not put w as having a value and just said it was a double. So you could just put double w and
Yeah.
then semicolon.
Oh, okay.
You don't need to put it to 0. You can,
Okay.
and you really should, but you didn't need to because
Oh.
it wasn't used anywhere in the code.
Mm-hmm.
Okay, let me plug in my Excuse me, can you plug this in? Thank you. Oh boy, we have a control thing. Okay.
Yeah.
So what you're gonna end up having here the words is gonna be like a switch statement. So what do you know about switch statements?
I remember you have to have like cases for them.
Yes,
That's
you
something
do.
I have, but yeah.
This one is like relatively poorly designed because there's no like catch case or like there's no else statement basically.
Yeah.
So if the value of p isn't one of those two values, it's gonna be like, what am I supposed to do? Like it'll just I have no idea what to do. But it is well architectured and then it has a break statement.
Yeah.
Because the reason that's important is that if you don't have a break statement, it's just gonna go to the next one in line
Oh, okay.
and then it's gonna go to the next one.
Yeah.
So I mean, obviously they won't trigger, but if you somehow have the same thing, it'll just be really weird,
Oh, okay.
and it'll waste processing time, right? So we have p is assigned 1, right? What is this again?
Oh,
What type of operator?
it will always make it true.
That is true, but what's the name of that operator?
Oh, it's it
Starts with an A.
Oh, is it and? No. Okay. Trying to think for a minute.
What does it do?
Assign?
Yes,
Yes,
it's
assign,
assignment
okay.
operator, right?
Okay. Assign.
Perfect. So you're assigning p the value of 1,
Okay.
and then you're saying switch p.
Yeah.
So it's saying, okay, whatever is in the parentheses, it's going to evaluate that, and then it's going to go to the case statements after that.
Yeah.
So p, there's nothing to evaluate there. It's just going to be 1.
Mm-hmm.
If you did p plus 1, if you did p plus 4, it would evaluate that and be like, oh, it'll be like switch 2, it'll look for a 2 value, or look for like a 5 value, something like that. So in this case, we have case 1. Well, that's what we want. We have p is 1, case 1, and then you just print case 1. We're done.
Yeah.
So return 0. The code is properly maintained. If they didn't have the return 0, it would be an error as well. So you need to make sure when you're watching this code, right, that the first part is good, that includes there, the main is properly done, and then the return statement is there.
Okay.
Those you need to check for every single time.
Okay.
Before you look into the logic of the actual thing.
Yeah.
Because the logic might be fine, but the outsides might not, and then
Okay.
they'll catch you that way.
Okay.
So in this case, it's just perfectly fine.
Mm-hmm.
What might trip people up? So in this case, in the case of this statement, it's okay because it evaluates to an integer.
Yeah.
You need this value to be an integer.
Mm-hmm.
So that means whatever's in here also needs to evaluate to an integer.
Okay.
So you can't have a double p. It needs to be an integer.
Okay.
So if it was double p equals 1, just you can automatically say, okay, it's wrong. It's 2.
Yeah.
Right? And so you have 1, and then obviously this evaluates to an integer as well.
Yeah. It would be 6.
Yeah, it would be 6. The switch statement was properly defined, and then you don't need a default.
Okay, but how did that work?
The default is the else statement that catches the edge cases.
Yeah.
It's good programming practice to have it,
Yeah.
but the program will still run if you don't.
Oh, okay.
It's just if something unforeseen happens, then it's just gonna be like, oh, it's due.
Yeah.
I don't know if this is what you do. Yeah, this was this, but I'm not.
So it's gonna be no errors.
Yeah, it's just gonna work.
I think I use.
Okay, did we? Was this
The stressful part?
the writing the program?
It's something silence.
Oh, okay, interesting. I actually have not looked at this. Was there a
Yeah.
part? Was there a part here?
Yeah,
that had
there's a
them?
part like right here. And yeah, coding is not my most favorite thing. Yeah.
I see. I see.
Yeah.
Okay, let's go through it then. Let me pull up my.
Yeah.
I took it. I took it last night. Second class.
Wait, what class?
Digital circuit. Yeah.
Oh, this is in Java. My bad. I have the C one at my home.
So whenever I show them this, they're like,
Well, at least this is the only CS class I have to take.
That is true. Yeah.
You're confused with what.
Okay.
I'm confused.
I don't really know how to implement it either.
So it looks like I took that class recently.
Let's go into it. So it's gonna be, you're gonna first obviously need to define the variables, right?
Yeah.
So
Like he did most, like he did actually most of it in class. I like just copied what he did, but it's not even
Cool.
coming out properly.
and then we need to prompt for that, right?
Yeah.
I
So
don't really care about that.
we're going
Like,
to.
this
I don't
part,
actually don't
like,
know
at
this. Do
least
you know what it is?
outputs.
It's
Wait, what is
Like, for
it?
example,
how do you
I
ask for
think
something?
add in stuff, so like.
How do you ask for something?
Yeah.
because it's,
Like, how do you,
zero, so it's supposed to be add, like, these sort of elements, one and stuff, so like, I just thought it was
Oh,
like
like
6
that.
plus 4 is 10. So if 6 plus 4 is 10, it's fine.
Got
And then
it.
since they want 7
I was just
plus
gonna be
9
yoink,
would be
actually.
16, but I
I
don't
just
know
I
why
will just
16
yoink
is
this
not
real quick,
outputting.
and then boom.
And then since it's minus, like 10 minus 4 is 6, and then 10 minus 5 is 2, but it's not outputting. Only the first one works. And then I'm supposed to like see out and carry out, but that's not coming either.
And then
I can like move it from here.
This one kind of makes sense. You only have 4 bits represented. Yeah. Right.
Yeah.
So this should kind of like not be represented because it's like you have like 2 to 4 things represent. So you have like 16 values represent. That's like 0, 1, 2, 3, blah blah blah, all the way to.
cool.
So you can't.
And then yoink this, and then copy that again. This one instead is gonna
I
be
think like
for
16
B.
is so.
Exactly.
Oh, so 16 can't come out?
So
I
we're
thought
just
it
gonna
would be
do the print
16,
statement.
and then since- I have no idea. So I was like, 6 plus 4 makes sense.
Yeah, you can't represent 6 because like okay, so imagine you have like the carry out and then you have the actual the sum. The sum can only go up to 1, 1, 1. This is 4, right? So that's 15.
Okay.
Cool. Let's see what happens.
Oh, so the sum would be 0 since like 16 is above 15.
Yeah,
Cool. We introduced the values, right?
Yeah.
So what else did it want? It wanted a few conditions to check, right?
Yeah.
So it wants if invalid values. So we're gonna use commas here just to determine it, so I don't have to keep looking over the screen.
Okay.
So invalid if. Actually, let me make this a multi-line comment. Close it here, right?
Yeah.
What is the first one? It's if A is greater than or equal to B.
B, or if A is less than or equal to 1, or if B is less than or equal to 1.
So less than or equal to 1.
May you explain the print and the scan?
Yeah, for sure.
Scanf, yeah, the printf and scanf a little bit.
For sure. Okay. So printf, right, is just going to be print format,
Yeah,
and you're going to put when whatever's in the parentheses, it's going to type.
yeah,
It's going to output to the system window.
okay.
So what this backslash here is called an escape character, and
Yeah,
what
yeah.
it does is it lets you type in specific commands. So that's how there is a line break after this,
Yeah, yeah, yeah.
and that's how there's a line break after this.
Yeah, yeah.
If I wanted a tab, I would put like /t. There's like a whole bunch of things you can look at.
Okay.
So
okay.
you should. I don't honestly have not. I don't have them memorized, but there's like a list that they have online.
Yeah,
This is just the most common one.
Mhm.
What we have right here, %d. Percent here is also an escape character,
Okay.
and D stands for decimal.
Yeah.
So decimal is another synonym for int. So whenever you're trying to
Oh,
refer to an integer, you're going to put %d.
Yeah.
And then what you need to do is you're going to need to tell it what variable it refers to. So
Okay.
if I try this, right, you need a and sign
Yeah.
as like a point. Sorry, as like a pointer.
Yeah.
Right now, so the double and is for the and operation.
Mhm.
The single and means
Yeah.
I want to look at the A box.
Yeah.
So the box that A contains, that's the value I'm going to look at.
Oh.
So
Okay.
you're pointing to that box,
Okay. Okay.
right? So we have %d, and you're telling it to look at the A box.
Yeah.
Then you're looking at %d, you're telling us to look at the B box,
Mhm.
and then you're doing the same thing. You can just put A and B. So
Oh, okay.
the and here also, the reason I don't need to put it here is that here it's also doubling as like an assignment. It's saying you're allowed to open the box.
Mhm.
Here it's
Yeah.
just saying look in the box and tell me what the number is. But this and here is going to be like, okay, you open the lid, put the value in.
Oh. Okay. Yeah.
So it's a shorthand for the assignment operator,
Mhm.
basically. Just how like plus plus is a way for you to go by and just be like an increment.
Yeah.
This is going to be like an assignment,
Oh,
a assignment, something like that.
Yeah.
So those are the those are the things that it's going to be like bad for. It's just going to stop the program.
Yeah.
What you'll eventually end up having to do is to prompt the user to re-input
Yeah.
the numbers, but here it's just saying to end it. So that's really simple to do. What you're going to do is you're going to put a few if statements. Obviously, because it has invalid if, right?
Yeah.
So if A would be, you can just put break. If A less than 1,
And he just looks at me like,
break.
you can't do it. And I'm like, "Professor, you're not helping." I can't do it.
So what that means is just going to stop the program. It's going to jump out of the loop.
Okay.
It's going to jump out of the main program and it's going to stop. At least theoretically.
Yeah.
Let's see. Okay, cool.
I was about to say.
Yeah, that's so we can only use that in a loop statement. Got it. Okay. So
This is what he. Is this a half matter?
Yeah. That's,
got it.
that's pretty much it.
So instead of the boxes, then you just put forgate?
That's this.
Oh,
That's
it is not Java. I can just,
That's it. There's just
I can
like
literally
a-
just put the,
and they have
I can tell the program to go and,
They see it fulfills this truth table.
because what's happening is that
Oh,
main is a function, right? And it's
Yeah.
supposed to return a value.
Mhm.
And if I tell it to return a value, it's gonna be like, oh, okay, my job's done here.
Yeah.
I'm done.
Okay.
So if A is less than B, it should fail, right? Or less than or equal to B. So I'll put A is 1 and B is 1.
Where you just copy that?
And it's just gonna finish.
Yeah.
Yeah.
We'll try it
That would
again.
make sure you understand why it
Put A is
looks
1 and then
I wanna
B
know.
is 4. It's done. Okay, so that means the first one is tested.
Yeah.
Then we're gonna put A is -1, B is -2. It's done. And then, sorry, if this one is, if B is less than 1.
Yeah.
That's why testing is important.
Okay.
So if A is positive and then B is negative, then it's just not going to return anything. So that is that portion of the code finished, right? Print on the screen the number of even numbers in the range of A and B. Okay. So my first thought is that
So what does a for loop? How does that work?
so let me finish coding this and I'll explain
Yeah. Yeah.
my thoughts. Actually, wait. It's not telling you to print them, right? It's just telling me to print the number.
Yeah. The number
Okay.
of even numbers.
So
number
if
of
I
even
have
numbers
one
in the range A and B.
is 6, right? So I have 6 and 4. Sorry, 6 and 1. I'm gonna have 1. So I do 6. It's It's 4. Okay.
I think I actually started from the truth table, and then I made everything else.
Okay. So I start with 2 and 8. Has 2 values.
It looks like this.
Two and 10 have 1, 2.
Yeah, looks right to me.
So that's, this is,
This is one. Yeah. Forty is because you have 4 bits you need to add.
I have to like do this 4 times.
You have to do it 4 times. I think. I remember I helped someone with the first part of the homework. The one where it's like, can you make the full matter? I mean, not
This one?
no, not this one. I think it was. Oh, actually, I don't know.
This is the first part of the homework.
Oh, okay. I think he was working on this one, but he was on this page. He was like, "Can you help me with this?" I was like, "Yeah." Basically, blah blah blah. You did what you just did right now. And, yeah, you already know how to make it subtract, right?
Yeah, but like it's not working.
Well, now that you have the gate level representation, you can check.
I'll actually do it like looking. That one.
Yeah, yeah. That's typically the first thing I do if I get stuff. Just try to get okay, so I have better. Oh yeah, that's it. I looked at it, I was like, okay, bro. I do, and that's it. But like we were like charged English. That was like I can see why she's about Later. It's good. It's filled up today. Bring lunch today or? No. Not helping your taste.
Those effects kind of weird. You get them off that. The other day I
Exactly, it's going like.
see, this is where I was mixing it up. This.
Which one? What?
So if CO1 and CO2 are
Oh, the two are-
connecting
Oh,
the
yeah, I've
full
been there before.
adders,
It's
then
like
why
super
does the
cramped,
professor
no
put
sunlight,
CO2
nothing.
Like this is one full adder, right? So, but he connects the one full adder to the second full adder, like with the wires.
Yeah, that's because they have a carry outs. So he's connecting the carry outs here.
We're going in there for 2336. I could not finish the life. Mohammed Bokhara. Thank goodness. I dodged Jesus with like a bullet. Sure looked. Penalties out.
So he's asked. This is why you're subtracting, because this isn't being XORed.
He's a weed out. He's a weeder out.
Okay, just selecting whether you're adding or subtracting. I assume that's what you're trying to do here, but it's just sitting there. It's not actually being used.
Oh,
So you should XOR the K selection function, which can be also CIN in this case.
Mhm.
It would be CI in this case. You should XOR CI B, which you did here. You didn't actually put it here.
so I would put X0, X1, X2, X3 over here.
I think I remember that's.
Oh, yeah.
But you get what I mean.
Oh, right.
Don't know if that should fit there.
The CI is just telling whether it's adding and subtracting, right?
Yeah, you also don't need CI. Yeah, but yes, CI out. But you don't define that as an output actually.
Oh. Oh. And then you said for this one, like,
Yeah.
do I put X0? Oh, I don't do this.
Or I don't know, just try out the X. Actually.
Oh, I know what you did. You said it now, I'm not getting it.
Yeah.
Okay, so it's just skipping the loop entirely.
I thought 10
Mm,
minus 4 was. I did the math before, I've done it. It's like 10 minus 4.
interesting.
This is pretty much what I said. So we have 0, 0, 0 and 1 secure. So we have a secure. So this is correct. So it's like this is 2.
That's 16, okay, yeah. So the adding, that one is fine. And I guess for the subtracting, like the sum, like, I don't think that's like 2 is correct, but.
I'm gonna go to the bathroom.
For sure, bro.
Okay, numbers.
Yeah, Linux is probably the
Oh.
easiest programming, but I don't.
Okay.
Wait, you need the
No, I got it.
You got it? Okay. I'll leave it up.
Oh yeah, yeah, that's fine.
If you use your eyes closed.
Mm.
Cloud crash for this would be crazy. Really smooth, real fast. I mean, this, yeah, I have these other days that it's like, so luckily, I go home like that. The problem is, I'll probably wake up at like 5 and be like, I feel like garbage. Be like, right now. And then I won't go to bed tonight. Not like it. That's why I time my alarm. Giving myself like an hour to sleep. Or else I just start like, it's literally like a second sleep. 7 apple. I don't know. I had a lot. I remember having just a lot. Like having just looking at these like. I was a little for that day too. I
Oh,
at
that's
least
what I know.
yeah. I mean, I'm not like super fat. I think right now I'm 175, 180. I need to reach. I think my max amount of weight I should be at is like 185, and then at 185 I just maintain. Well, I cut ish kind of. Okay.
Can you come
I
over?
need people to be well, over 95 pounds, like no like fat on it, none of that. That's what I'm trying to aim for.
Okay, I like that idea.
That way I don't
I
lose too much mobility,
got,
but I still have enough strength to where I can get burpees.
I'm talking about the carry out.
Oh, you just.
That's something.
If there is no.
And bodybuilding, I like the way I look, but
I thought you had for the.
you gotta use the muscle for something.
Yeah. Like walk. I'll run away. That is not what I meant. I guess because Verilog doesn't convert it to, Verilog doesn't output it in Blender. It outputs it in Decimal. So that's why I'm a little bit like confused. That's pseudo. Otherwise, I would and I'd be like, oh, right, so that means honestly,
Okay, I got the first two test cases working.
Okay.
I just need to figure the problem one. But okay, let me walk through this. I think the people tuning online saw most of it. But first I started off with like the numbers and I saw what was expected. So that's what basically there was the three cases. If both are odd, both are even, or if one is odd and the other is even. Those are the two numbers, right? So also we had realized we did this wrong. It was supposed to be if greater than.
Yeah.
So I fixed that up real quick.
Yeah.
And so I have the number stored as b minus a, and that's going to be like the subtraction. So number, I think, can actually just be product. No, I'll just put it as number. It's fine. And then have integer I initialized here. I initially wanted to go with the for loop, but that was a bit hard. And I realized I needed to do two different while loops. One if either one of the values is even, then I need to do this while loop, and if
Yeah.
both of them are odd, then I need to do this while loop.
Oh, okay.
So this is the or operator, and so that means if this is true or this is true, then I go into this loop.
Yeah.
If neither of them are true, then I'm gonna go into this
You're
one.
gonna go into else.
Right.
Okay.
So it's a 1-1, it's 1-0, or 0-1.
Yeah.
So what this means here, did you guys go into the percent sign? Like the
The
It's just like
the percent sign.
Mhm.
Yeah, we gone over a little bit. I
Okay.
can't remember. I can't remember exactly, but like.
let me get like a solid definition
Yeah.
for you.
But the problem, yeah, he wants us to like.
What is it called?
He wants us to like. And so like the and or not add stuff.
Stephanie, do you know what the percent operator is called?
Modulus.
Modulus. Yeah. Modulus operator. God. I just used it, but I didn't remember what the name was. So it just it returns the remainder.
Oh, okay. Oh, okay. Yeah.
So the reason I used it in this format is that if the remainder of the division by 2 is 0, then it's going to be an even number.
Yeah.
Does that make sense?
Yeah. It makes.
And if so, it's like 4 divided by 2 is going to remain 0.
Yeah.
And then like if b has a remainder of 0 as well, that means b is even. So this is basically saying in coding terms. Let me comment it. If a is even or b is.
Oh, okay.
So if a is even is what this means.
Yeah.
Or if b is even
Yeah, I was like.
is what
well,
that means. Yeah.
yeah.
Let me just do that real quick.
I was like, what is B again? I was like.
Yeah.
Here,
So b is that second value.
Yeah. Okay.
And then if both of those true, you do this
Yeah.
while loop. Otherwise, you do this while loop.
Yeah.
The reason it's like this is that if if one of them is even, then you can just subtract and then divide by 2, or divide by 2.
Yeah.
And the number of times you divide by 2 is what you has is the amount of even numbers in between.
Yeah.
So if you say start with like 2 and what did I use? 2 and 10,
Yeah.
right? We have 4, we have 6, and we have 8. So there are 3 even numbers in between. If we subtract 10 and 2, we end up with 6.
Yeah.
And then 6 is divisible by 2 3 times.
Yeah.
So we have 3 even numbers in between. That's how if both of them are odd. That'll happen for all the odd numbers. So say 4 and 8. There's one odd number and 6. But there's one even number 6 in between them. So 8 minus 4 is
So obviously the homework should be
4.
4. So you go one number in between
Just
them.
don't copy it, guys.
Oh, okay.
Wait.
Oh, okay. Yeah. Gotcha.
I do the same thing.
Right. And then we have while number is less than 1, then you have to do it. This one's less than 2. This one's less than 1. Because when you're subtracting the odd numbers, you need to stop at 1
Yeah.
and not 2. So that's just how that's there. The average was pretty simple. It was just, you have to store them as a double, and then you have to do double division, and then you also have to this point 2 is how many decimal places I'm doing,
Yeah.
right? So it's gonna be 6.00.
Yeah.
Right. Cool. And then the pattern, I guess, we can just do.
Oh, so that would be.
You're starting to realize that?
Mm.
Yeah, you fucked up.
Yeah, something like that. Each second's supposed to be.
Were you thinking power electronics or something?
No.
It's supposed to be how it's specified.
I was thinking about that one, but I was told not to do that one,
No.
actually.
Don't.
So I didn't.
As of right now, is getting.
I'm dropping that class respectfully.
Oh, power electronics? Yeah, it's hard.
Nothing is a prereq and then like.
The professor's fine. The coursework is rough.
Yeah, that's what I heard. I heard the homework last time is
Pain. Okay, sorry, let me go. So the plan for the pattern is like what they described, right?
Yeah.
I'm gonna go for printing the amount of like asterisks.
Yeah.
So I need to start with 0 and then print as many as I can.
Yeah.
whole day to do everything.
So I think I'll start. What I need to do. I need to go from 0 to the number. Okay, so int 0 equals int I equals 0, sorry. 0 and then 0, oh, sorry, I is less than the number, and then I'm going to increment I. Right, and so starting here, I'm going to do print f, just going to be one of these asterisks. And I think I can put another, I'll put another loop in here.
Oh, okay.
0, p is less than I, equals x. So the reason I'm doing this is I wanted to print the inside the asterisk I number of times.
Oh yeah.
Okay. Actually, I don't even need to put I. I can put B here. And then I can put it starts at A. No idea if this is gonna work. Probably should put this thing here, and then we'll go from there. Okay, no errors, promising. Okay, I'm gonna need to put a line break after here, so each thing looks distinct.
Do you live like around here or no? Oh. That's 20 minutes. Yeah, okay.
These modules.
No, he told us to make.
So we start from 2, and then we go until 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that is the pattern.
Okay.
And that's it.
Oh, okay.
It's just that much more convenient.
We can also just do it from, we can start at 0 and then go to B. So 2 to 10, 1 to 3 all the way until this.
Is it 8 or 9?
1, 2, let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Starts 9.
Yeah.
So I want it to be less than or equal to B. So it'll print it 10 times. Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Oh, okay.
So printed it 10 times. Yep. That's pretty much it. And so that's the assignment. Took a little bit, but it is what it is.
Basically, I just need to practice coding and just understand it.
Okay, damn.
So, this is basically spotting patterns and then implementing them from how you do it. If it was something else, you would have to figure out what you need to do is you need to figure out what you want it to output and then figure out how to manipulate the data you have coming in to get the output that you want.
Okay.
So here I manipulated what I had, translated it a bit, and then put it into code.
Oh, okay.
Realistically, you need to use paper. It's just I've been doing it for a bit, so I could just put my ideas here. But usually, what you need to do is you need to put the flowcharts. You need to define your variables. You need to be like, okay, I want to do this. Like using a pen and paper will save you some time up front. Well, sorry, it'll cost you time up front, but it'll be smoother to execute the program later when all you need to worry about is syntax afterwards. So actually, let me save this. Yeah, and I think that's pretty much it for this assignment. I'll copy this and I'll put everything on like a little Google Drive. And I think that's going to be it for that meeting as well. So I will, yeah, I'll post everything in a Drive folder. So thanks guys for tuning in. I will see you all next time. Peace.
Okay.
So